Hello, geometry students. Today we are actually going to start working on proofs. This is kind of the meat of some things we're going to do in geometry, so it's going to be really, really important that you do have the sound on and that you're listening to my explanations of what's happening. If you are just copying the notes without listening, you're going to miss out on a lot of it, and then you're just kind of wasting your time, really. So let's make sure we're paying attention and listening. All right, so today we're reasoning with algebra. Again, we do want to make that pop. Okay, so grab a highlighter or something so when you are looking back through your notes trying to find something, you can find the title of the lesson very quickly and easily. And so what are we going to do today? We're going to apply properties of equality and congruence to prove problems involving algebra, and then justify each step in a proof, okay? So what is going to be really important today is making sure that we study really hard and memorize some of these properties, which many of them you already know, okay? And what you probably learned already in our last lesson when we talked about conditionals and biconditionals and converses and inverses and contrapositives, the vocabulary really does matter, and you have to be very precise in the way that you communicate, okay? So keep that in mind. It's not okay to just give a generic statement. You have to be very, very particular about what you say to prove what you're trying to prove. Okay, so first of all, what is a proof? A proof is a mathematical argument that lays out step by step, how to get from a starting point, which is usually your hypothesis. Now remember, with a hypothesis, there's no if in there, but that's basically the if part of the statement, or it might say given, okay? To an ending point, which is often the conclusion, which is the then part, okay? And I'm just kind of going to add off to the side. You will often have given and then prove, okay? So, types of proof. There's lots of different types. This is just kind of for your information. Proofs are typically shown as two-column. That's what we're going to spend most of our time doing, okay? Two-column proofs. That's like making a little table. But there's also flow proofs and paragraph proofs. And that's basically taking information in the column where we say, we make a statement, we give a justification. That's what a two-column proof is going to be. We're going to like make a table. And then you can take those and write them in just different formats. We'll get to that later in the year. Okay, each step in a proof must be justified. Okay, you can't just say it. You have to give a reason for it. Okay, so it's like you're a lawyer. You're a lawyer in court. You have to back up every single thing you say with evidence that has already been proven. Okay, you can't just make stuff up. All right, so the justification of each proof uses learned definitions, postulates, theorems, properties, and more. Okay, that's a lot. So what this means to do is you have to study. And study needs to be active, meaning you're interacting with the information, maybe 3x5 cards, quizzing yourself, okay, moving around, you know, adding some, like maybe little arm movements or something, or a little dance you make up. Something that's going to actually make this stuff stick in your head, okay? Just staring at it on paper is not going to do it. All right, now, here's the fun part. This is going to be a super boring part of the lesson because we have to learn all these. Now, let me break it down just a little bit. These first four, you already know these. You have been using these in algebra since probably at least 7th grade, okay? So you know them. Now we're just going to have to state them. So every time you solve an equation, if you add the same thing to both sides of the equation, that's the addition property of equality. So if we start with a truth statement, A equals B, if I add C to both sides, C representing some number, it still stays true. So if A equals B, then A plus C is equal to B plus C. Okay, same thing. If I subtract the same things from both sides of the equation, it remains true. So again, if I start with A equals B, then A minus C equals B minus C, okay? And these letters are just representing numbers or variables you're going to be using. Multiplication property of equality. If you multiply both sides of the equation by the same thing, the equation stays true. So again, we start with A equals B, So multiply both sides times C. A times C equals B times C. All right, division property of equality. Again, divide both sides. Now we typically use that use a fraction bar for that. And very important, C can't be 0 because we can't divide by 0. That's all that little thing means. So if we start with A equals B, we know we can put a fraction bar under each one, divide it by the same thing on both sides, and it remains equal. Okay? So you should already know those. You just have to be able to state them as you're using them. Okay? Let me skip a few and come down to two other ones you already know. Okay? Again, you've been using these in algebra all the time. Okay, you know. And this is also stuff you already know. Okay, substitution. We use this all the time when we solved systems of equations. Okay, if you remember from Algebra 1B, we did systems of equations. Or was that 1A? I think it's 1. Yeah, that was Algebra 1A. Okay, so pretty much if you have two things that are equal, you can put one in place of the other. Okay, so if A and B are equal, then B can replace A in any expression. Okay, so keep in mind when you did solving systems of equations by substitution, we just plugged something else in. Or this is what we would use when we would evaluate an expression. If I would say, evaluate x plus 1 for x equals 3, you would just put the 3 in place of the x and know 3 plus 1. All right, distributive property. Anything outside the parentheses gets multiplied by anything inside. So remember we used to draw those like little rainbow arcs. So A times B plus A times C equal. And of course there's a subtraction version of that as well. Now that brings me back to the new ones, okay? And these are, you are going to have to work hard to memorize these, and some of them may not make sense. If I recall, we use some of these more during second semester than we do this semester. So if you have a break, or if you're going to summer school or something, you might have to come back and remember these. So reflexive property seems like a duh moment. The reflexive property means that a number is equal to itself. So A is equal to A. So a number equals itself. Okay. Symmetric property. If A is congruent to B, we can flip that around. So if A is congruent to B, or even if A equals B, then B is congruent to A, okay? Okay, that's like saying, an example would be like, x is equal to 3, so 3 can be equal to x. We can just reverse that order, okay? So reverse order. And then the last one is the transitive property. So if A is congruent to B and B is congruent to C, right, then A is also congruent to C. Okay, so let me see if I can think of a real life example. Nothing's coming to me in mind. I should have thought of that before the lesson because I don't want to waste your time. All right, so I'm going to pause the video here, and I'm going to just make like a separate video maybe for each page so that each video can be watched individually, okay? All right, I will see you on the back page.